All right, welcome back, everybody. Today we are going to be talking about, I think it's actually called SR3 in your note packet. I believe there's kind of like a little typo and a little bit of a difference between the note sheet that I have in front of me and the one that I think I printed you, but we're just going to kind of try to match up everything the best we can. So here's what will really tell you that you're in the right place. We are talking today about how we simplify radicals with variables, right? So that is going to be our focus. Now, when we come over here, we've kind of been working on this a little bit, but we're going to amp up the difficulty today. Now, we've been simplifying these things all along. So when we get something like this, and we're being asked to simplify the radical, we know that our method to break this down is to go through and to look at the prime factorization of each number. So in this case, I can see that 32 breaks down into 5 2's. So when I come over here and I rewrite this, I could rewrite it as 5, and then I normally leave a little bit of space, and I have all those 2's, all 5 of them. Now, the way this process goes is if you have 2 of the same thing, you can pull one of those to the outside, and then you cross them off on the inside. Here's another 2 2's, so I'm going to be able to pull another 2 to the outside, and I cross those out. Now, if you notice, we still have 1 2 that is remaining inside, so I can come over here, keep that 2 inside, and then to figure out the outside number, this isn't 522, those all get multiplied together. So 5 times 2 gives us 10, 10 times 2 gives us 20. So our final answer is 20 square roots of 2. Now, this process is fairly easy on radicals that are just containing numbers. Now, when you start to get letters, it gets a little bit stranger. Now, looking at this one, again, you process it the same way. You break down 25. That would break into 5 and 5. Now, we're not going to talk about the a squared here, but we will talk about it in a minute. So when I rewrite this out, I'm going to be able to write this into 5 and 5 because those were the prime factors of 25. And then, since I have a squared, that just really means a times a. So you want to actually string out those variables with the exponents. At this point, we do our 2-for-1 special again. 2 of the same thing, pull 1 out. 2 of the same thing, pull 1 out. Now, since there's nothing left inside of my square root, the square root essentially disappears and it will not show up in our answer. Over here, we multiply outside numbers. Even though a is a variable, it still works as a number here. A times 5 is 5a, and that will be our answer. Let's take a look at another one. Here's another one. Number 5. So 125n. Here's how we're going to go about it. We're going to have 5 and 25. We're going to have 5 and 5 breaking off of there. So when I rewrite this again, I don't even worry about the n right now. I'm going to have my square root of 555. And then I do have that 1n that is in there as well. Just like we did before, 2-for-1 special. You get 2 of the same, you pull 1 out. So I'm going to have 5. These 2 cancel out. Square roots of 5n. And just like that, we're done. Now, it's important to remember the reason we still have a 5 inside of our square root is because we still had a 5 inside of our square root that wasn't able to be pulled out. Same thing with the n. We only had 1, so you can't pull it out. We always can only do a 2-for-1 special. Looking at problem number 7, here's another one. So 12 would be 4 and 3. 4 is, almost said something wrong there, 2 and 2. So let's break that down. We're going to rewrite it as 2, 2, 3. 2, 2, 3. Now in our original, we had 3 x's, so we're going to be able to write that as x, x, x. Now we look for those 2-for-1 specials. We do see a 2-for-1 special here, and we see a 2-for-1 special here. So we get a 2 and an x that come out. Remember to cross out the stuff inside. Now we do still have stuff remaining inside of our square root. We had a 3 and we had an x, so those are going to stay right here. And then on the outside, x times 2 is just going to give us 2x, which will make this our final answer. Right? So the process overall isn't extremely difficult, but it is a little bit different because of how you think about those variables. Let's get to some really good problems. Here's a really good problem. Number 9. So coming over here to work through this one, what you're going to want to do is you want to break this down. 64 is going to be 8 and 8. If I get 8 and 8, that's going to be 4 and 2. and 2 and 2. And then this will be 4 and 2 and 2 and 2. So I do have 6 2's here that will form the prime factorization of 64. So when I come over here and rewrite this, again, let's leave some space. So here's the 2 that was already on the outside. Here's the space I'm going to leave, and there's my square root. So now I'm going to have 6 2's. Now I know space is going to be a little condensed here, so one trick you can use is to kind of stack them 2 on top of each other. There's my 6 2's. I also see that I have 5 m's over here to consider. So I'm going to do that same trick of stacking them 2 on top of each other. And then I also have 3 n's to consider. So I have n, n, n. Now, coming over here and looking at this, we do our 2-for-1 special. C2, pull 1 out. C2, pull 1 out. C2, pull 1 out. Now I'm going to use my space. I'm going to slide this 2 over there. So I have 4 2's that are being on the outside right now. So 4 2's, 2 times 2 is going to give us 4. 4 times 2 gives us 8. 8 times 2 is going to give us 16. So the number on the outside of my square root will be 16. Now let's think about the variables. So right here I have one group of m's and another group of m's. So I'm going to be able to pull out 2 m's, and the way we say 2 m's in math is m squared. So I'm going to have m squared on the outside as well. And then finally, I'm going to be able to pull out one group of n's. So I'm going to have n to the first, or just n. Now inside the square root, I can see I still have stuff remaining. It appears I had an m and an n, but there is no number remaining. That's okay. So I'm just going to keep my m and n right in there. And we're done. Right, so this 2-for-1 special is really a good way to think about this. It helps us organize our thoughts. Oh, let's maybe do one more. Let's pick a toughie. I think, like, honestly, the hardest looking problem, 11, 13, 14. Oh, let's do 15 here. Here we go. This will be a good one. Now, there's kind of a shortcut if you know anything about 144 that you could utilize here. If you're like, I don't know how to play that in with these variables, then just follow me and let's break this down the normal way. So 144 is 12 and 12. This is 6 and 2. This is 3 and 2. Same over here. This is 6 and 2 and 3 and 2. Now when you come over there, that means our prime factorization will be 2 3's and 4 2's. So when I come over here to rewrite this, I'm going to do this one below. I'm going to have 2 2, 2 2, 3 3. Now let's talk about our x's for a minute. So for the x's, we have 2 of them, so I'm going to have xx. For the y's, we have 10 of them, so I'm going to have y, 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 and y. There's my 10 y's. The nice part about stacking these up in groups like that is you can already see the groups. And then we have one z, so the z is going to sit over here. Now we pull out our 2-for-1, so we have 2 2's, pull out a 2. We have another 2 2's, pull out a 2. We have 2 3's, pull out a 3. These are all gone. Since we have no more numbers to pull out, when I multiply these, I will get my final number, so let's do that now. 3 times 2 is 6, 6 times 2 is 12. I'm going to have 2 x's, or I'm sorry, 2 x's on the inside, so I can pull out 1. 1 group of y's, 2 group of y's, 3 groups of y's, 4 groups of y's, 5 groups of y's means y to the 5th on the outside. And then on the inside, we still had one z that was stuck in there that didn't get pulled out. So he's still sitting right there, which makes this our final answer. Thank you guys so much for watching this full video. If you have any questions, please do not be afraid to reach out and ask. Thanks, guys. Have a great day.